Now, a somewhat similar idea to our fundamental counting principle brings us something called permutations. Permutations are just ways that certain objects, that a certain number of objects can be ordered. So the big idea with permutations is that order matters. So I'm going to write that in a different color, star it, put a bubble around it, just so we remember that, hey, permutations, order matters. All right, so let's think about this for a second. If we have 3 objects, I'm going to say I have 3 objects, objects A, B, and C. Let's list out the different ways that these objects could be arranged. I could start off with object A. And if I have object A, then I could go ABC or ACB. If I start off with object B, now I have 2 letters left, A and C. I could have the A come first, I could have the C come first. If C comes first, then I could have CAB or CBA. Okay, so there are 6 possible arrangements. If our order matters. I guess one of the easy ways to think about a permutation is, let's say we have a race. How many ways could we have for second and third place? So order matters there because it matters who wins the race. It matters who gets second. Okay, so we have 6 possible arrangements there. This brings us to something called factorial. Okay. So if we think back to our fundamental counting principle, this leads us again to this idea of factorial. The fundamental counting principle, we'd have 3 possibilities for the first space. We could have letter A, B, or C. 3 possibilities for the first space. But now for the second space, we only have 2 letters left. So there's only 2 possibilities for the second space. And now if we've already used 2 letters, we only have one letter left. So only one last possibility there. 3 times 2 times 1 gives us our 6 possible arrangements. So this idea, this 3 times 2 times 1, is what we call 3 factorial. Okay. That little exclamation point is called factorial. And I don't know if you guys have seen this before or not. This might be something new. But when we see a number factorial, that just means we start with the number and then decrease down. So 8 factorial would equal 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we decrease all the way down until we get to 1. Right. And again, this idea of factorial really stems from our fundamental counting principle. So let's do a couple examples here. Example 2a, using our permutations. How many ways can you arrange 9 CDs on a shelf? So we're saying here it matters how we have these CDs arranged. Okay, how many different ways can we arrange them? Well, thinking through that fundamental counting principle again, that first spot on our shelf could have 9 possibilities. Now we only have 8 CDs left. So times 8, times 7, times 6, and all the way down. Because then eventually we're only going to have one CD left, and that has to fill in that last spot. So instead of writing this all the way out, 9 times 8 times 7 times 6, we could just write 9 factorial. And we can type this in our calculator. 9 factorial we can type in. Again, instead of having to do 9 times 8 times 7 times 6 all the way down. On our calculators, if you look at this math button here, or I'm going to hit the 9 first. So hit the 9, and then if you click math, go over to probability here, the prob at the top. Option number 4 is your factorial key. Hit enter. This tells us what the 9 times 8 times 7 times 6 times 5 all the way down to 1 gives us. 362,880. That is a lot of possible ways that you can arrange your CDs on your shelf.